working on with Con Edison is we're really thinking, they're thinking in terms of what happens now when you have lots of distributed energy on the system. How do you get all this information back into the distribution network, essentially? And what we came up with in this project is this is just a small portion of the types of what they call advanced distribution operational strategies. And I'm going to show you a little example of one of them where if you look at a couple of square blocks in Manhattan, there's transformers on the streets, and there are meters, and there are load controllers, and there are energy management systems, and possibly backup generators in the buildings. Traditionally, the way demand response would be done is that there's a signal from the system operator or the distribution operations that are somewhat far away from where the building is, telling it to be part of a demand response program. So things we're working on is localized intelligence, where if you look at the transformers and you put an agent on there that monitors its temperature, and we've got some equations on there that can tell when it's overheating and what other characteristics are happening when it needs to be unloaded. This is one of our guys that says drop an agent in, excuse that part. The agent will actually be able to communicate from the transformer to the load controllers on the building and to provide this localized control. The reason this is different is that now we're really kind of responding to the network locally. And this is just one example of how that can be done in terms of how agents can coordinate locally to make the grid more reliable. Let's skip these slides. Go to the end here, because I really would like to get people discussing this and open this up instead of just me talking about it. But in terms of distributed intelligence and control, a really huge issue, an open issue, is the delegation of authority for agents to actually do things. Because if they have to make fast decisions, most utility engineers are being behind the control board. They're the Wizard of Oz, and they want to make all the decisions. And so, what we're doing right now is we're providing a lot of this information as lists of potential things that could occur at different cost points and different contingency rates, and let the actual network operator decide which one of these control strategies to utilize. But again, if this is going to become a self-healing, semi-autonomous grid where these decisions are being made quickly, who's going to give that permission? And that's a big issue. And I think the other thing is that when we went into this, I've been doing this for a long time, and in terms of these agent-based controls, 2002, no utility on the planet, there was lots of IEEE papers on this, but no network engineer would understand what you're talking about or want to go there because of the fact that there really isn't a real-time two-way communication infrastructure for one in most utilities. The AMI deployments are getting closer to this, but even AMI may not be what we need. And the second part is, if you want to put an agent on a device, you need computational capacity and hardware to do that. And what we've designed our agents for is actually to run on these little devices that are a little embedded Linux computer that are the size of a piece of gum. We think now they might be able to be put on a meter board, but we're still a ways up between putting this some of the sophisticated computational capacity at the edge of the network. So what we're doing now is we're actually picking up a lot of information from the more centralized systems, and we're modeling them with agents, and then we're essentially using our controls and our software to think about managing the grid that way. In the future, I do believe that with the cost points going down and with smart meters getting a lot more robust and the boards being able to be replaced, that you'll see a lot more computational capacity at the edge of the grid, and distributed intelligence will become much more a part of the solution. So I will close with those remarks.